Hello students, Ms. Slyman here with your notes on 8.8 implicit differentiation. So an implicit equation is one where you have x and y together on the same side of the equation or mixed up in the equation, products of each other, something like that. So it's not explicit. And if we look at some examples, so explicit is all these over here where we've got y by itself. And all of these are implicit, they've got y mixed up with the x. So we're going to learn to differentiate those. So let's look at an example of an implicit differentiation, equation of a circle. X squared plus y squared is r squared. And we're looking at our tangent line here. So we go through the point 2 and 2 root 3. So the tangent line slope, if we look at this slope and try and count it, well, I'd say roughly, we know that here we're at 2 root 3, and up here we appear to be at about, I don't know, 5.7. So we could count that. That looks like it goes, even if we just look at boxes, we're going down about, I don't even know how much that is, some amount, and over 2. So if we look at that, that looks to me sort of to be in the ratio of like -1/2. So I'm going to go with approximately -1/2. Okay, so to find the derivative, we could make it explicit. So I've got x squared plus y squared is 16. Y squared is 16 minus x squared. Let's make that x squared. Y is equal to plus minus square root 16 minus x squared. It does not simplify. So now if I want to find the derivative, I would have to do 2. So if I look at both of them separately, so my first derivative, dy dx, is going to be equal to 1/2 16 minus x squared to the -1/2 times -2x. That's just chain rule. So that's the derivative of the positive version. Our second derivative, the derivative of the negative version, is going to be -1/2 16 minus x squared to the -1/2, and then times the inside, -2x. Ah, that barely fits. So if I simplify this, then what I find is that my 1/2 and my 2 are going to cancel. So the 1/2 and the 2 cancel. And then I'm left on with this left equation with -x over root 16 minus x squared. And then on the other side, we've got the -1/2 and the -2 are going to cancel with each other, and we've got on that side x over square root of 16 minus x squared. And this makes sense because as we look around the circle, then we can see that the derivative could be either negative or it could be positive. We have both kinds of slope. So it makes sense that we have two different derivatives that give us a negative or a positive slope. And so there are the two options of the derivative. However, a lot of times it's not possible to solve explicitly for y. So we need to use our techniques that we've been learning, chain, product, and quotient rules. So let's look. So differentiating with respect to x, and we're thinking of y as a function of x. Well, here we just have function of x. So using chain rule, our derivative is going to be 3 times the inside, don't change it, change the power, times derivative of the inside. So that was our chain rule. Okay. This one is another chain rule, so we're going to have 1/2 times y to the -1/2, and now times the derivative of the inside, dy dx. And if we wanted to simplify this, we would end up with dy dx being multiplied by 1 over 2 root y. So notice that we have both a derivative and the y in there, and we don't know what y is, so we can't simplify this any further. Okay, separate this into parts. So 2x is derivative of the first part, chain rule for the second part. 3 times derivative of f of x. It's not even chain rule, I shouldn't have said that. This is just a constant times f of x. So we keep the constant and multiply it by the derivative of f of x. Okay, this one, again we're going to do it in parts. 8x plus 3 plus, now we have product rule. So derivative of x is 1 times y plus x times derivative of y. And then we need chain rule, 2y plus 3 to the power 1 times derivative of the inside, which is derivative of y. And since we don't know what y is, we can't simplify our derivatives anymore, and we can't plug in the y. Okay, so now we're going to differentiate with respect to t. So derivative of h with respect to t is derivative of h with respect to t. Derivative of 4t cubed with respect to t, 12t squared. 3t is just 3. Okay, left side is going to be chain rule, 3z squared times derivative of z with respect to w. Now if we differentiate the right hand side with respect to w, we're going to get 4w plus 1. So since we don't know what z is in terms of w, we have to also have the derivative of z in terms of w. Okay, again chain rule, 4y cubed times derivative of y with respect to x plus 2 times derivative of y with respect to x equals 3x squared. So I can just take the derivative of x cubed because it's only in terms of x. Okay, again we have product rule, so we're differentiating with respect to y this time. So derivative of x with respect to y, well that's dx dy, and then we multiply it by the y, plus x times derivative of y with respect to y is just 1, derivative of 6 is 0. So to differentiate an implicit function, we differentiate both sides and isolate our dy dx. So in this case here, we could have isolated our dx dy quite easily. We could have said that dx dy is equal to x divided by y. Sorry, negative x. So we would move our x over and then divide by the y. And sometimes that's going to be easy for us to do. So let's go back to our first circle function. Differentiating it implicitly, we're going to get 2x plus 2y times dy dx. We're differentiating with respect to x equals 0. So 2y dy dx equals negative 2x. dy dx is equal to negative x over y. And it turns out I was wrong about my slope then. Well, actually, I was okay. Because now if we plug in our point, we know our x and y. So at 2, 2 root 3, then the slope, the derivative, is equal to negative 2 over 2 root 3, which is negative 1 over root 3. So I was off by, it's not quite a half, but I was pretty close. So the derivative depends on both x and y. This means we have to know what y is in some way if we're going to find out what that derivative is. So let's look at this one. Find dy dx. First one is product rule. 1 times dy dx plus x times 1. Sorry, we don't know the derivative of y. It's dy dx. Sorry, let me start over here. Okay, so product rule, derivative of x with respect to x is 1 times y plus x times derivative of y with respect to x equals derivative of y with respect to x plus 0. Too big of an eraser. Okay, we're going to isolate our dy dx's, so that's going to give us 1 equals dy dx minus x dy dx. Well, we can factor out the dy dx and get 1 minus x, so dy dx in this case is equal to y divided by 1 minus x. If I wanted to go further, I could come back to my original and try to isolate y. Doing that would be the same as explicitly differentiating it. So if I isolated y here, I would have y times x minus 1 equals 5. So then my y value is equal to 5 divided by x minus 1. I could come back and plug that in here, and I should end up with the same derivative as if I would have derived this one initially. So, if necessary, we can go back and find our y and plug it in. Since this doesn't tell us to find it only in terms of x, we can leave a y in there. That's okay. Again, we have product rule, and this time it's product rule, just product rule. So derivative of x squared is going to be 2x, so times the 3, we're going to get 6x times y plus 3x squared times derivative of y, which we don't know. 1 over x, we know of course is x to the negative 1, so that's going to turn into plus 1 over x squared. Derivative of 6 is 0. If I want to isolate my dy dx, I'm going to have 3x squared dy dx is equal to negative 6xy minus 1 over x squared. Divide through everything by 3x squared. Dy dx, negative 6xy divided by 3x squared minus 1 over 3x to the 4th. And I can simplify a little bit. Negative 2y over x minus 1 over 3x to the 4th. So there's my derivative. It's in terms of both x and y. Okay. This one's chain rule. So half y to the negative half times derivative of y plus half x to the negative half equals 0. 1 over 2 root y dy dx plus 1 over 2 root x equals 0. Dy dx is negative 2 root y over 2 root x, which is of course just negative root y over root x. Product rule plus chain rule, 3x squared times y squared, that's part of my product rule, plus x cubed times 2y to the power 1 times derivative of y, there's my chain rule, equals 0. Negative 3x squared y squared divided by 2x cubed y is dy dx. And of course we can simplify. Dy dx is negative 3y over 2x. Okay, so here we have a graph of this crazy function at x equals 4. So there we are. Here's our point. Notice that if x is 4, we can figure out the y. So root y equals root 4y minus 2 root 4. Root y equals 2 root y minus 4, because of course square root of 4 is 2. 2 times 2 is 4. So move over the root y, we get 1 root y equals 4, square both sides, y is 16, which makes sense for our point here. So we've got the point 416. So we have an x and a y, and now we need a slope. So to find our slope, we're going to do the derivative. So we've got root y equals root xy minus 2 root x, half y to the negative half times derivative. This is chain rule hidden in product rule. So we've got a half times the inside, xy to the negative half, and now we need to multiply by the derivative of the inside, and that's our product rule. So I need some space here. I'm going to move this y equals 16. So okay. So here's our outside for our chain rule, and now I need the derivative of the inside. So that's going to be 1 times y plus x times dy dx. And now we need the derivative of this bit, which is negative 1 because of the 2 times a half, x to the negative half. And now I'm going to plug in my x and y values. I know my x and y values, so I'm going to plug them in. So 1 over 2 root 16 dy dx equals a half of root 4 times 16, that's 64, times 16 plus 4 dy dx minus 1 over root 4. We can simplify all that to solve for our slope. So we're going to end up with 1/8 dy dx equals 1/16, and then times 16, that's nice, that'll be 1 plus 1/4 dy dx minus 1/2. So go ahead, find your dy dx. I don't have space here, so find your dy dx, use that slope and this point to find the equation of this line. You should end up with a y-intercept really high up and a slope that's both negative and fairly steep. And there you go, your notes on implicit differentiation. I will see you in class.